We might expect that a new, revolutionary idea is needed to solve this problem. The revolutionary idea, which is the most promising, is that the universe is made from tiny pieces of string. This idea is a great departure from the ideas of Newton, where the fundamental objects are particles moving as points in space. If the fundamental object is now a string, then it can be either open with two ends or closed with no ends. We must now consider what happens when strings collide, split, and join. When a string vibrates, such as a violin or guitar string, it can produce many different notes. The basic idea of string theory is that the different fundamental particles in nature are simply different vibrations of the same piece of string. Thus, a single string can represent the whole array of subatomic particles. One could say that the music of strings is particle physics. Every theory of physics makes predictions. For the case of relativity and quantum mechanics, these predictions were verified with remarkable precision. When this is the case, we can safely say that the theory is correct and describes the universe we live in. For the case of string theory, the predictions are extremely difficult to verify directly. Two main predictions stand out. First, string theory predicts that the universe has 10 dimensions. In addition to the familiar 3 dimensions of space and 1 dimension of time, there are 6 extra hidden dimensions of space. You may well ask, how can this be? We do not experience any extra dimensions in our daily lives. According to string theory, the 6 extra dimensions must be curled up into a tiny ball, so small that we cannot detect them even with our most powerful measuring devices. Second, string theory predicts that the universe is supersymmetric. What does this mean? We are familiar with many fundamental particles in nature. When we examine their properties, we see both similarity and diversity. Supersymmetry is a special type of symmetry that predicts the existence of a whole new family of fundamental particles, called superpartners. The idea is that each fundamental particle in nature has a superpartner, whose properties are very similar but subtly different. In order for string theory to be a viable theory of everything, supersymmetry must exist in nature. In other words, the universe must be supersymmetric. To test string theory, we need to find evidence of supersymmetry and extra dimensions of space. The natural place to look is in the high-energy collisions taking place at CERN and also at a similar facility called Fermilab in the US. While we must wait patiently for experimental verification, string theory has already passed an important theoretical test. It has successfully explained the structure of black holes inside the event horizon. Since we believe that black holes are the key to the universe, string theory has made great strides in understanding this key. Our final image is of a string and a black hole. Black holes in the universe are large, massive objects with incredibly strong gravity. They remain hidden from view. String theory predicts that the universe is made from tiny pieces of string. Because of their small size, these are also hidden from view. The ultimate goal of physics is to construct the theory of everything. At this point in the 21st century, the most promising candidate for this theory is string theory.